About the grades because Mr. Ferris tries to have my back, so he's counting and he knows that we don't have all the 60% grades we're in. Well, you and I both know that I have a chapter 2 60% grade that I just haven't graded yet. So we do have another 60% grade we're about to put in. And then there are 2 more 60% grades coming up next week. So it should be the 6th. I'm confused about the counting. So if we counted the 6th, I'm sorry, we're going to count out loud because otherwise this conference is going to be distracted the whole day. So let's see. We had the Unit 1 test. We had the perfect squares test. We had the first Chapter 2 test. Now we have the second Chapter 2 test. That's number 4.
That's a lot.
And then, number 5 is going to be the math workshop test. And number 6 is going to be a test on just 3.1. So, and I'll say all those things again. So yeah, we've got the 6th by next week. Okay, so in case you haven't realized that, this is week 8. Next week is week 9. We're reaching the end of the 9 week. So if you missed the test, yay, so exciting. So if you missed the test, or if you've not made something up, you got to get on it as soon as possible so we can get your life right. Because, my gosh, if you think I just love it when people hand me a bunch of work week 9, I don't. I don't. Please don't do that to the poor little Miss Compton. She's been working so hard. Don't do that to me. Okay, so, before we even go over these math workshops, let's talk about next Tuesday. 100% promise, no doubt. We're going to take a math workshop test. It is the end of the 9 weeks. It is time. If you haven't been here for all the math workshops, that's fine. It's going to be fine. I'm going to keep that in mind when I grade yours. I will keep that in mind. It would be smart of you to write that note at the top, like I was out week 1 through 4, or like I think Jonathan missed week 1, so I missed week 1. Like, I appreciate that note. If you're still wanting to be on top of things and you won't, because, you know, I make 1 every class period, so I've got 3 for this week. Like, yay, I have 1 for every class period. So if you're wanting, like, if, it's not true, he was here the whole time, but if Xavier missed week 2 and he needs mine because he was not in our class week 2, he needs to just ask me. And I will gladly give him my copy even. That's not a big deal to me because I have lots of copies of them, as you can see. So the math workshop test is going to be next Tuesday. We've discussed this before, but let's discuss it again so me and DJ are on the same page. Is DJ getting his math workshops on the math workshop test? No, he's not. It's going to be similar questions to what we've been doing. So he might be given a similar factoring problem. He might be given a similar radical that he's supposed to simplify. In fact, on Monday, I'll be nice and we'll look back through all the different math workshops we've had, and I'll be specific and I'll say, sure would be smart of Andrew to study week 2, number 3. Like, we'll do that next Monday to make sure he knows exactly what to study. But Abby Grace, I'm about to brag on her, and I need to brag on her all day, and I'm going to brag on her this series. Abby Grace, when she studies, she makes notes to herself. Let me show you what she does, if you don't mind. Because it was the most genius thing I've ever seen. If I could show all my people all day, every day what she did, they would be impressed. So, Abby Grace studies ahead. So she's going to go ahead this weekend and study her 8 math workshops to make sure, and if there's one she's confused on, she'll come see me 0 period next week before this math workshop test happens, because that's what you're supposed to do. So here's her study guide from the last test. So she puts, not only did she turn it in and do all the problems and staple additional, like how she went through it, but she puts check marks if she really understands something. Like, I totally get number 1. And then she puts, like, okays when she's kind of concerned she might mess it up, so she needs to study that again. So she feels okay about graphing piecewise, and she's especially concerned about getting the range of a piecewise. I love that. You can see how she studied. You can see what she was worried about. That's genius. I wish, I think I might, if it's okay with her, I might white out her name, make a copy of her study guide, and yeah, y'all know it's her. But every other class period will not know it's her. We can talk about how that is good studying habits. Because, my gosh, if we all had that kind of studying habits, we'd all have an A in altitude tray. Yeah, because she's not perfect. Everybody's, even Miss Compton makes mistakes. But I really like her studying habits specifically. Very good. Okay, so moving on from Abby Grace's good study habits. Since she does have good study habits and she's hearing us out loud, and there are many other in the room who have good study habits, they're just not showing it the way she did on her study guide, which is fine. It would be smart to go ahead. I got someone in the back that do. I know they have good study habits. it would be smart to go ahead and look back through those math workshops and make sure you're comfortable with everything. And if there's one that you really didn't understand, come see me or ask during class before it's too late. Okay, so let's go ahead and go over these 3 math workshops for today. I need help with number 3. What goes into 26, 18, and 32? Yes, Travis? 2A. And what would you be left with? 13B plus what? Okay, then what? Perfect. And your group can have a point. Is there anything else we could do? We have 3 terms left. Eventually we're going to get to the point where we can factor after this. Can we in this problem? No, we're done here. So we're going to move on. Are there any questions about number 3? Well, let's go on to number 4. Drea, yeah, I saw that hand up, but Abby Grace is ready to steal if you don't got it. Yes, ma'am. You did grouping. I know what you did. She grouped. And grouping is what we're going to go to. But what is our first step? Before we group, what should we look for? A GCF. So she's right if we go to that. So we're going to give Drea a point because if she started off grouping, she's grouping well. But there is a GCF that you can pull out first instead. Yes, Abby Grace. Oh my gosh, get that off my desk and move on with your life.
All 4?
Yes.
Wait, you can pull out all 4?
Yeah, there's a number you can pull out of all 4. Does anyone know the number you can pull out of all 4? Yes, Travis. 3. You can have a point. If you pull out a 3, you're left with what?
7K third.
7K is the third, and then what?
28K squared plus 5K
28? That sounds right. Okay, now plus 5K
minus 20.
minus 20. That sounds perfect. Okay, but now Drea's right in that there are 4 terms, and we can group with those 4 terms. So, not using the 3, we're going to group with the 7K cubed minus 28K squared, and we're going to group with the 5K minus 20. So, in fact, I'm going to make sure that 3 is so separate, I'm going to put a giant bracket. That way we don't even try to put 3 in this mess. Okay. Looking at that 7K cubed minus 28 squared, 28K squared, what can we factor out? What can we factor out? 7K what? And your group gets a point. And we're left with K minus 4. And that's from that first term. And then with that second term, 5K minus 20, what can we factor out of it? And what are we left with? K minus 4. Okay, and then Miss Compton is super duper happy right now. Why am I happy? Why am I happy? Why do I know we did it correctly? How do I know we're right?
Because K minus 4 is
Oh, and everyone was energetic on that. Because the K minus 4s match. So my final answer would read what?
Okay, 3 7K
Square plus 5. And then K first.
And then K minus 4. How many points you'll have, Travis? How many points you'll have, Abby Grace? Abby Grace and Travis get a point. No. You were just super distracting. No offense. Yeah. But you knew that. Okay. Are there any questions about number 4? Number 6 is going to be even more of a pain in the tail. Let's go to number 6. Does anyone tell me from the get-go why number 6 is a giant pain in the tail? Really big numbers. And does everybody have an N? No. So can't factor out an N. What number can we factor out?
5.
And that's why it's super annoying, because I thought it was going to be higher than that. So, and then Travis is waiting to dying to answer the question. He didn't know the question I'm going to ask. Maybe he can answer it anyway. I wanted to factor out a 25, because I noticed 75, 125, etc. Or, so I thought.
But then you looked at one.
But then I looked at what, and I knew that it couldn't work. 105, and everyone knew that. Every group can have a point. 105 is not divisible by 25. So the best I can do is factor out a 5. When you factor out a 5, what are you left with?
21 into the third power plus 35 in the square minus 15 minus 25.
Oh, Travis, are y'all now at 5 points if I give you a point?
Wait, what?
If I give you a point, are you at 5 points?
Gave us 1 point.
Okay, you're already at 5 points?
So we're at 4.
Okay, well, I'm not going to let you go to the 5th, even though you're a genius today, because you know why. Because you realize, you get why, right? Okay. Travis, in fact, I'll let you go to a 5, and how about I just keep that person in mind, that person can't have the 5. How's that? I'm that good. Okay. Let's go to the next thing. How many terms are there left in the parentheses? How many terms are left?
4.
So what can we do?
UCF.
We're going to do grouping. So, and I'm going to put the negative inside the group. So, that one's inside the group. So, I'm going to put that 5 on the outside of the bracket because I don't want to even think about the 5. He's not involved in this grouping process.
7n squared.
What can I factor out of 21n cubed plus 35n squared? And Travis is right, 7n squared. I'm left with 3n plus what?
5.
Okay, so that's from that first term. And then with that second term, what should I factor out? And he is going to be sad. What should we do instead of 5? We want to do negative 5. Dre, I get a point. We want to do negative 5 because then we would be left with 3n plus 5. And then we'll be happy. If Travis only factored out a positive 5, he would not end up getting the same matching things, and then he would be sad. Our whole point with grouping is we better get the same thing in both sets of parentheses, or else we've not done grouping correctly. Okay, so from here, our final answer would be what?
5, 7, 3 minus 5, parentheses 3n.
Perfect. Perfect. Xavier, you had a question.
I was going to say that's always the case.
If you've done it correctly, that should be the case. If they're not matching, you've messed up. You've messed up. Or it could have never been done to begin with. There is that potential. But when it's real close, like Travis probably would have realized, I have a negative 3 and minus 5. The sides are wrong. I should have factored out a negative. Travis is that good. And so are you. Okay, are there any questions about these math workshops? I got about 1 per group having a lovely phone day. You have a math workshop test next Tuesday regardless, and it's going in that 60% category. So you were so proud of your 89, 92, 75, whatever grade you had. It's going to go down if you don't pay attention to math workshops. My goodness. Okay, let's go to your new packet. Oop, I'll leave it. Let's go to your new packet and let's talk about how sad it is because it's homecoming week. You just took a test. And I hand you a giant new packet, and here, let me make it a little sadder. This packet is only on, really, the study guide says 3-1, 3-2, 3-4, but really it's 3-1 and 3-2. And let's be honest, the first chunk of it, the first chunk of it, only the last 3 pages are not 3-1. The first, whatever this chunk of pages is, 6 pages, 3-1, that's how much is in 3-1. That's why I'm saying we're going to take a test when we get done with 3-1 because 3-1 has a lot of information in it. Now, while it does have a lot of information, Jessica's seen this information before. Unlike Piecewise, this is not a new thing. This is a topic she's talked about before. Her algebra teacher taught her how to deal with systems of equations. She's already done solving by graphing, substitution, and elimination before in the past. Yes, we're going to review it, and it's going to refresh her memory, but you've already done this in your algebra class. This is not a brand new topic. You've done it before. Today, good grief. Today, we're only going to talk about graphing. Tomorrow, only substitution. Friday, we're going to have a checkpoint that has graphing and substitution on it. Okay, so let's look at our first page. So solving by graphing sounds easy, and it really is. Because if you're good at graphing. If you're not good at graphing, then, algebra 2 with tricks is going to be hard anyway. But if you're good at graphing, this is going to be an easy section. The hardest part of solving by graphing is the vocab we need to know. So, in fact, that first little box, I would put a star next to it and say on test. Because the vocab, I know, because I just looked at the 3.1 test. Vocab is the first part of the 3.1 test. Do you know, and we're going to talk about 4 major vocab terms. Do you know the 4? The first part of our next test is going to be on the 4 major vocab terms we're about to go over. And in fact, the first blank is system of equations. And that's not even one of the major 4 vocab terms. I don't even, in my mind, I feel like you would have guessed that one anyway. That's not even one of the 4 I need Andrew to memorize. Okay, so we're going to talk about a system of equations. And eventually we'll be so fancy that we'll have 3 equations. But for now, a system for us, 2 is enough. So a system that has the same variables. So notice in our first problem that this first equation has x and y. The second equation has x and y. If they have different variables, we can't do this. They have to have matching variables. Okay, that was just a side note. Now for the 4 vocab terms. Systems of equations can be classified by the number of solutions. We have 3 different options for our numbers of solutions. We can have 1 solution. We can have no solutions. Or we can have an infinite number of solutions. And even though Xavier remembered that, sadly, he probably doesn't know the vocab term corresponding to each of those, and that's what we're about to discuss. So, a system is consistent if it has at least 1 solution. What do you think is the opposite of consistent? Inconsistent. So it's going to be inconsistent if it has no solution. So, and I'm sorry, but paragraph form does not help me at all, so I have to make myself a list. Consistent, 1 solution. I put SLTN for solution. It's an easy way to abbreviate. Inconsistent, no solution, but I'm going to put a line through my zeros so people know it's a 0. No solution. So that's the first 2 vocab terms Andrew needs to understand. Consistent, inconsistent. Consistent means 1 solution. Inconsistent means we have no solution at all. Yes, dear.
Slightly unrelated, but a lot of people just take out the vowels with their abbreviated like that.
I don't know. That's a good question. I don't know. This is sad. I just know how math professors abbreviated solution, and this is how they abbreviated solution. But you're right. It's the vowels that left. Strange.
It's not just in math either.
But with like variable, we do VAR. We leave the A. We're not very consistent. We're not very consistent with our abbreviations. And then asymptote's the worst because you really can't abbreviate it because you want to put like AS and then you end up like spelling out a bad word. So I always spell out asymptote. Anyway, that's another thing another day. Okay, inconsistent, consistent, and then our next vocab terms are dependent and independent. So we're going to put independent first. They can be independent or they can be dependent. Okay, if your system has exactly 1 solution, that 1 solution is unique, it is special, and just like someone else who is unique and special, it is independent. So if it's 1, it's unique, it's special, it's independent. And that's how I abbreviate independent, and it does have vowels, haha. So again, independent is still with that 1 solution. But the reason we have 2 words for that 1 solution is because independent means it is a special, unique solution. That's why we have to add that second word. It describes the solution a little better. Okay, and then the second word is dependent. And that's when we have infinitely many solutions. So it's not special because there are lots of them.
So
Yes, dear.
if it's consistent, it's also independent?
Yes, so we're going to list 2 words. So we might say, if we say inconsistent, we're done. But if we say consistent, we then have to clarify. Are we consistent and independent, or are we consistent and dependent? So there are a couple examples where we're going to have to use 2 vocab terms. Okay, and then so I'm glad that Xavier is stressing over the vocab terms already, because Xavier needs to pay attention to the directions. Because it says solve by graphing, but it also says Andrew gets the other half of his points from using the right vocab terms to describe the graph. So if Andrew's graph is no solution, he better have that word inconsistent in order to get all of his points. This is a vocab, very heavy section. If you don't put the right vocab terms, you're not going to get all your points. Okay, so since we're supposed to be graphing, no offense, those words are great, I don't understand unless I see it with a graph. So I have to draw myself a little tiny graph. So I'm going to draw 3 tiny graphs to illustrate this point to myself. Or to try to help you with it. Okay, so I want my graphs to have one solution, no solution, and then, of course, infinitely many solutions. If my graph has one solution, all that really looks like is 2 lines that cross. So I have a line, I have another line that crosses it, and that spot where they cross, that point, that is our one solution. What vocab terms should I put with this kind of a graph? Consistent, independent. Jessica, you get the point. You need to have both, consistent and independent. That is correct. No, does not. My gosh, then we'd be really picky, wouldn't we? Okay, but you're smart and you've graphed a line before. What would it look like if my graphs had no solution? Brady, that was the fastest anyone's answered that today. They're parallel, and then Travis was right behind you. So Brady, you can have the point. Travis will let you have it. They are parallel. What word should we write if we have no solution and we see these parallel lines? Inconsistent. Lyric had it too. And Travis, I know you have it, but don't y'all high five? I'm going to let Lyric have that one, and I'll let you have it too. Yeah, he says, but I could get more. Okay, and then we get to the last one, which is they're the same line. Travis knew it. He can get the point. So you think, Miss Compton, are you lazy? You only graph one line, but the lines are the same line. They ended up being on top of each other. They had all the same points. They are the same line. We only graphed one line. They were the same line, or whatever. And what vocab terms should we put with that? And, yeah, so consistent and dependent. I didn't have someone say both, so I'm going to keep that point to myself. Consistent and dependent. Andrew, were you the one that said dependent?
No, no.
Okay.
I said, yes, ma'am, but...
I'll give you the point. You need a point.
Woo, yeah, boy.
Because he's not helping you get any points today. Okay, Travis, you got a question? No, there could be. So we're eventually going to get to 3 systems, but for now, before we scare anybody too much, let's just handle the 2 for a while. Yes, and then it would be where all 3 cross. So if they don't all 3 cross, they don't all 3 have it. There's not that similar solution.
Wait, repeat that. If they don't all 3 cross on
At the same
spot,
point, yeah.
then what?
Then that wouldn't be the solution. They wouldn't have a solution.
They'd be inconsistent?
Yes.
Okay.
Yes.
I was just about to ask that.
Yes. Yes, dear. It would still be that there was that one solution at that one spot where they all 3 met. I swear you're scaring the others. We'll get there. We'll get there.
Okay.
Okay, so let's bring it back to reality before we try to make life too hard. Back to our first problem. It says, and I've written on top of it, so let me write it to the side. It says x plus 2y equals 6, and it says 2x plus y equals 9. Okay, so I'm looking at those, and I'm mad at the form they're in. What form are they in?
Standard.
They're in standard form. You read this point. They're in standard form. We got a problem. I can't graph in standard form. Gonna have to put them in y equals mx plus b and get y by itself like Travis is wanting to do. So for that top equation, if I subtract by x on both sides, I'll have 2y equals negative x plus 6. If I divide by 2, I'll get y equals negative 1/2 x plus 3. Are there any questions about my work in gray? Well, I mean, I could go ahead and graph that line. So let's see, my intercept is 3, so I go up to 3. My slope is negative, so my line should lean to the left. So down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, up 1, left 2, up 1, left 2. So if Abby Grace is struggling with graphing, and she's not, this is not going to be her favorite section, because if she can't graph correctly, she's never going to figure out the solution. Okay, and hopefully her dots were connected a little prettier than mine. That was not my prettiest connecting today. Oh well. Yes, dear. Oh, thank you. Okay, and then if I want to rearrange this other equation, if I subtract 2x from both sides, I would have y equals negative 2x plus 9. But what stinks about that one was easier to solve. However, if I go up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9's not on the graph, so we just kind of have to estimate. My slope is negative, so it also should lean to the left, so down 2, right 1, 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 and I kept on going even after I crossed it because I like graphing. Now, Travis is already on it because he's already trying to put the right vocab words. So, yes, we're going to say since there was a spot where they met, it is consistent and it is independent. And while he's getting all his points on the test, because he has graphed, he has used the right vocab terms, I'm interested in where that point is. What point is the solution? Eventually that will be useful, but for today it just makes me feel better to know the exact spot, like it happened here. Okay, are there any questions about that first one? That second one is going to be just as much fun. So if we rearrange that top equation and we add x to both sides, we would have y equals x plus 5. If we go to that second equation and we add 2x to both sides, we would have 2y equals 2x plus 8. If I divide by 2, I get y equals x plus 4. And I'm a smarty pants, and Travis, don't answer because I know you're a smarty pants like me. I'm a smarty pants. I already know the answer from here, simply from those two equations. Now, I'm a good student, so I'm going to graph anyway, but I already know the answer from those two equations. What is the answer? Yes. It's inconsistent because they have the same slope, different intercepts, so they're going to be parallel. So, yes, the vocab term I should put is inconsistent. Now, since we are overachievers and it doesn't take long to graph those two lines, especially since the slope is 1, should we put 1, 2, 3, 4 our intercept and graph them really quickly and show they're parallel? I'm sure that wouldn't hurt. But yay, if you can recognize it before you even graph it, that makes your life so much easier. Yes, dear. Okay, are there any questions on number 2? I try. It does not always work. Hello, dear. Ooh, there's a packet stapled on my desk that you want. A giant one. It's underneath my grade book. I see it. Okay, let's flip to the back to number 3. Well, I help her get that. Oh, she's smart. She got it herself. Good. Thank you, dear. Okay, let's flip to the back to number 3. We're only doing 4 today, and then there are 3 you ought to do in your workbook, but, you know, life is what it is. Jerica, you're going to break her heart. But here, you could, I don't care if you send my fee. Or she can or you can. I don't care. That's fine. You were trying to get closer to the board. No one can be mad at that. Okay, number 3 is a fun one. I rearrange that top equation. I subtract 3x. I have 2y equals negative 3x plus 12. I divide by 2. I get y equals negative 3 halves x plus 6. Are there any questions about my work in gray? Okay, well, I need to rearrange that other one as well. So I subtract x from both sides. I have negative 2y equals negative x plus 4. If I divide by negative 2, I get y equals 1 half x minus 2. And again, Miss Compton is a smarty pants. I know the answer from here. Does anyone else know the answer from here? Do they have the same slope?
No.
So are they parallel?
No.
Are they the same line? No, so it can't be the infinitely many, it can't be the parallel, no solution, it has to be one solution. So what words should we put? Consistent and independent. Now, Derica is an overachiever, and I appreciate that about her. So she is going to graph them anyway, because the directions did say graph. She puts her intercept at -2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Now, another reason Derica knew that these lines were going to cross is because one had a positive slope and one had a negative slope. Of course they were going to cross. That makes logical sense. Okay, I graphed the pink one. Now for the gray one. I got to go up to 6. 1, 2, 3, 4, 5, 6. Did I count 1, 2, 3, 4? I did. I've got to go down 3. Right 2. Down 3. Right 2. Down 3. Right 2. Down 3. Right 2. And then I connect my dots. And I'm happy because they crossed, and I can even tell you where they crossed. Can someone tell me where they crossed? Thank you, Brady. Get another point. 4-0. So yes, they crossed, and we put the right vocab terms. But again, I think it's important to note where they crossed, because eventually we're going to learn how we can use those numbers to further check ourselves and make sure we're not crazy. Okay, I like you get excited, so I'm really excited about number 4. Are there any questions on number 3 before I go crazy on number 4? Travis, if you steal my joy on number 4, I will cry. And put the other word with it, DJ. How many points y'all got, DJ? Add 2. Okay, so Travis and DJ have already figured out my favorite problem of the day, because number 4 is my favorite. Number 4 is my favorite, and I know the answer from here. I know the answer without graphing. I know the answer without putting in y equals x plus b. I am that good, and so are you. Okay, DJ said dependent, which means infinitely many solutions, which means they're the same line. How did he recognize they were the same line from these two equations? But you can't tell slope and y-intercept from here. Can you? The variables look similar, like maybe they're multiples of one another. So, for instance, let's divide the top one by 2. If we divided the top one by 2, we would have 2x minus y equals 3. What if we divided the bottom one by 3? Then what would we have? Huh! They are multiples of each other. That one was multiplied by 2, that one was multiplied by 3, but really, secretly, they're the same thing. So if you're smart enough to realize that, well then, my gosh, you're like DJ, you were smart enough to realize to begin with, consistent, dependent. Now, does DJ need to do the rest of the work because the directions did say graph? Yes, he does. But the fact that he recognized this, then if he gets 2 lines crossing, he's done something wrong. He was supposed to only get 1 line because it's supposed to be infinitely many solutions. So while this is great, that's not really what he was supposed to do. But he's genius for realizing that. Okay, so he's supposed to do what we've been doing. So he needs to rearrange this equation. He subtracts 4x from both sides. He got, yes. So he subtracts 4x. He's got negative 2y equals negative 4x plus 6. He divides by that negative 2. He's got y equals 2x minus 3. Negative 4, negative 2 is positive 2. Positive 6, negative 2, negative 3. So he goes down to negative 3. He puts his intercept. And then he's really excited because he's got to count up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And he just goes down, down 2, down 2. And he's got this beautiful line. And that's great. But he still has to graph the other. So he sees this other equation. He subtracts, it's supposed to be. He subtracts by 6x on each side. He gets negative 6x plus 9. But some people won't recognize it until they do all the work every day. He divides by negative 3. he gets y equals 2x minus 3. Now, maybe you're having a blood moment and you don't realize those are the same equations. So Xavier again goes down to -3, puts his intercept, counts up 2 over 1, and the next thing he knows, he has gray on top of pink, and he's graphed the same line on top of his original line. If that's not further proof that it was infinitely many, which is consistent and dependent, I don't know what is. However, someone's going to make a mistake. Yes, sir.
I've never had a student like do that and then get it wrong in terms of vocab. Like they'll do it and they're like, oh wait, it's not.
Oh, yeah. Oh, yeah. That's what I'm telling you. Vocab will kill you this section. But what's even worse is someone's going to get this wrong. So DJ recognized that they were supposed to be the same line, but he is a human and he made a mistake. Where would DJ make a mistake if he was going to make a mistake? Where did he mess up in here? Somewhere in there. With the sides, Travis. Travis, you're genius. And so this is what, Travis could be a math teacher because he tries to figure out what people do wrong, which is what I do all day. So what people would do wrong is -4 divided by -2, they wouldn't get +2. Or -6 divided by -3, they wouldn't get +2. People don't watch their signs. They end up getting -2x minus 3. Or they get like 2x plus 3, and they don't end up with the same equations, which means they don't get the same graph, which back to if we just had DJ's common sense to recognize to begin with, hey, we were supposed to get the same graph, maybe then Sarah would be smart enough to go, hey, I was supposed to get the same graph, so I've made a mistake. Let me figure out where I went wrong. Okay, that one was my favorite. Are there any questions about that? Okay, well then you have 6 minutes to either work on your workbook, be quiet and not annoy me, or I'm going to look through your test and see if you need to be if you're one of the ones who are the blind. Oh, let me tell you what you did. I forgot to say that. I had some people who, God bless them, on 17 and 18 on their test. It's the last two. It was the graphing inequalities. They had a graph. They even paid attention to doing dotted or solid. I'll give them that. What did they forget to do?
Shade.
They didn't shade. I've had like 4 from each class who didn't shade with the graphing inequalities. Makes me a little sad, not gonna lie. But I'm gonna let you fix it because you had a blonde moment